Hello, good morning to everyone. Welcome back to ACT Mathematics class 12th. In this important notes quick revision, and class is 12th. Chapter 7 is integrals. Chapter 7 is integrals. Let's see what is the integrals. See, first topic is in integrals indefinite integral. See, what is the definition of indefinite integral? Integration is the inverse process of differentiation, that is dy by dx of f of x equal to small f of x. That implies integral f of x dx equal to f of x plus c. This is the general form of the integral, indefinite integral, where c is the constant of integration. Here c is the constant of integration. Integrals are known as antiderivatives. So integrals are known as antiderivatives. So this is the integral general form. Okay. Next, some standard integrals. Let's see some standard integrals. Integral dx equal to s plus c. Constant also you should write compulsory, x plus c, where c is the constant of the integration. Where c is the constant of the integration. Next one is integral x and dx value is x power n plus 1 by n plus 1 plus c, where n is not equal to minus 1. Where n not equal to minus 1. If n equal to minus 1, then what happened? See, x power 0 by 0. Something by 0 means, x power 0 means 1, 1 by 0 means infinity, right? This value is not exist, it's not defined, right? So that's why where n is not equal to minus 1. This is the second standard for integral. Next, integral e power x dx value is e power x plus c, where c is the constant integration. Next, integral a power x dx value is a power x by log base e a or log a base e. You can read as log a base e plus c, where a is greater than 0. Integral a power x dx value is a power x by log a base e, where a not greater than 0. Okay, this is the next standard integral. And integral 1 by x into dx value is log mod x base e plus c, where x not equal to 0. Where x not equal to 0. So these are the some standard integrals. Okay, these are the some standard integrals. Okay, you should remember in our mind. These are very simple. Integral dx value is x, and integral x power n dx value is x power n plus 1 by n plus 1, and integral e power x dx value is e power x. Integral a power x dx value equal to a power x by log a base e. Integral 1 by x dx equal to log mod x base e. Right. Next, integral sin x dx value is minus cos x plus c. Integral cos x dx value is sin x plus c. Integral secant square x dx value is tan x plus c. Integral cosecant square x dx value is minus cot x plus c. Integral secant x tan x dx equal to secant x plus c. Integral cosecant x into cot x dx equal to minus cosecant x plus c. So these are the integrals of trigonometric functions. Okay, so these are the integrals of trigonometric functions. We should remember these are some standard integrals of trigonometric functions formulas also. These are very easy, and we should find the problems also by using these standard integrals. Okay, integral cosecant square x into dx value is minus cot x into plus c. Next one is integral dx by square root 1 minus x square value is sin inverse x plus c minus, or another one is, or another one minus cos e inverse x plus c. See, this value equal to sin inverse trigonometric functions. Sin inverse x plus c minus cos inverse x plus c. Next, dx by 1 minus x square value. Integral 1 by 1 minus x square dx value is tan inverse x plus c. That equal to minus cot inverse x plus c. Next one is integral 1 by x into square root x square minus 1 dx value is secant inverse x plus c, where, and another one is in cosecant inverse also minus cosecant inverse x plus c, where mod x is greater than 1. And next integral tan x dx equal to log mod secant x plus c, log mod secant x plus c minus log mod cos x plus c, minus log mod cos x plus c. Okay, these are the some standard integrals. So you should remember in your mind this one. Next, integral cot x into dx value is log mod sin x plus c. And next one is integral secant x into dx is log mod secant x plus tan x plus c. And next one, log mod tan of x by 2 minus pi by 4 plus c. Next one, integral cosecant x dx equal to log mod cosecant x minus cot x plus c. And another one is log mod tan x by 2 plus c. Okay. Next, properties of indefinite integral. Next topic is properties of indefinite integral. Integral f dash of x into dx value is f of x plus c. Next, second one is integral f of x into dx equal to integral g of x into dx plus c, where f and g are indefinite integrals with the same derivatives. Next one is, third one is integral f of x plus g of x into dx equal to integral f of x into dx plus integral g of x into dx. Next, fourth one, integral k into f of x dx equal to k into integral f of x into dx, where k be any constant real number. So these are the properties of indefinite integrals. Next one, methods of integration, methods of integration. Next topic is, and first one, what is the method? Integration by substitution. What is that? Let's see what is that. The given integral f of x dx can be transformed into another form by changing the independent variable x to t by substituting x equal to g of t. So this is the integration by substitution method. Let's see. Next one is tables. These are integrals and substitution. So integral f of ax plus b into dx value is ax plus b equal to t, small t. See, in place of ax plus b you can put t, we will write integral f of t into dx, correct? And g of x equal to t here, substitution, and integral is, see here, g of x equal to t and integral is integral g of x into g dash of x into dx. Okay, next one is substitution is f of x equal to t, then you will write integral f dash of x by f of x into dx. Next, f of x equal to t, then integral of f of x whole power n into f dash of x into dx. Next one is integral p of px plus q into square root cx plus d into dx equal to, so this value how much? Px plus q equal to a into cx plus d plus b. Here substitution is px plus q equal to a into cx plus d plus b. Find a and b by equating coefficients of like powers of x on both sides. Or this in this, or this one, or this integral also you can write integral px plus q by square root cx plus d equal to dx. These are integrals and these are substitutions method. Okay. Next, same in that table only, these are integrals and this column is substitutions. Okay. So what is that remaining continuation? Integral 1 by px plus q into square root cx plus d into dx. Here you substitution cx plus d equal to t square. Okay, and in this integral 1 by px square plus qx plus r into square root cx plus d into dx, you can write px plus q equal to 1 by t, and here is in this also cx plus d equal to t square only, both r it is there. For these two integrals you can write this substitution only. And last this one, integral 1 by px square plus q into square root cx square plus d into dx equal to x equal to 1 by t, and then c plus dt square equal to u square. And this one also, in this integrals also we can substitute this one only. Okay. Next topic is integration using trigonometric identities. Trigonometric identities. Integration using trigonometric identities. When the integrand constants of trigonometric functions, we use known identities to convert it into a form which can be easily integrated. Some of the identities useful for this purpose are given below. First one is 2 into sine square x by 2 equal value is 1 minus cos x. The second one is 2 into cos square x by 2 value is 1 plus cos x. Next, 2 into sin x cos y equal to sine of, can written as sine of x plus y plus sine of x minus y. 2 into cos x sin y, this value is that equal to sine of x plus y minus sine into x minus y. Next, 2 into cos x into cos y equal to this value is cos of x plus y plus cos of x minus y. Next, 2 into sin x sin y means just change the sign, minus. And first one you can written cos of x minus y minus cos of x plus y. Some special substitutions. Let's see some special substitutions. Here square root a square minus x square, this is expression, and substitution is put x equal to a into sin theta or a into cos theta. And second one is square root a square plus x square or a square plus x square equal to, here in this you can substitution is put x equal to a into tan theta or a into cot theta. And second one is square root x square minus a square values, you can put it x equal to a into secant theta or a into cosecant theta. And square root a minus x by a plus x or square root a plus x by a minus x value also can substitution this, put x equal to a into cos 2 theta, and this one put x equal to a into sin square theta or a into cos square theta. And here from this expression you can put x equal to a into tan square theta or a into cot square theta. And last one, square root a minus x by x minus b or square root x minus b by a minus x values, in this also can substitution x equal to a into cos square theta plus b into sin square theta. So these are the some special substitutions by putting x value in trigonometric functions. Okay. Next topic is integrals of some particular functions. First particular function is integral 1 by a square minus x square into dx equal to, this value is equal to 1 by 2a log of mod of a plus x by a minus x plus c. Next one is integral 1 by square root a square minus x square dx equal to sin inverse x by a plus c. Sin inverse x by a plus c. Next one is integral 1 by square root x square minus a square dx equal to log mod x plus square root x square minus a square plus c. Next one is integral 1 by square root x square plus a square into dx equal to log mod x plus square root x square plus a square plus c. And fifth one, integral 1 by x square minus a square into dx equal to 1 by 2a into log mod x minus a by x plus c, x minus a by x plus a plus c. Integral 1 by x square plus a square into dx value is 1 by a into tan inverse x by a plus c. These are integral some particular functions. Next topic is integration by partial fractions. See, next topic is integration by partial fractions. Let's see what is the important notes in this topic. If f of x and g of x are two polynomials such that degree of f of x is greater than or equal to degree of g of x, then you divided f of x by g of x. Therefore, f of x by g of x equal to quotient plus remainder by g of x. This is the general form of the integration by partial fractions. Okay. If f of x and g of x are two polynomials such that the degree of f of x is less than degree of g of x, then you can evaluate integral f of x by g of x into dx by decomposing f of x by g of x into partial fractions. So, partial fractions, okay. So, this integral f of x by g of x into dx, you can substitute in this form quotient plus remainder by g of x. So, then this method is called integration by partial fractions, okay. Next table, see the table, form of the rational functions, and second column is form of the partial fractions. See, first one in this px plus q by x minus a into x minus b, a not equal to b. In this you have to write form of the partial fractions a by x minus a plus b by x minus b. And second one, you can write form of the partial fractions from this rational function a by x minus a plus b by x minus a whole square. And third one, px plus q by x minus a whole cube, be this one a by x minus a plus b by x minus a whole square plus c by x minus a whole cube. Next, this form of the rational function p x square plus qx plus r can written as a by x minus a plus b by x minus b plus c by x minus c. And next one also x minus a whole square into x minus b, only denominator changing here, form of the rational function. And here capital A by x minus a plus b by x minus a whole square plus c by x minus b. And last one is px square plus qx plus r by x minus a into x square plus bx plus c. This one value you can written a form of the fractional fraction is, final answer you can write a by x minus a plus bx plus c by x square plus bx plus c. So, these are the form of the rational functions, and finally have to write form of the fractions, partial fractions, okay, form of the partial fractions. Next, integrals. In this integration by parts, so next topic is integration by parts. If u and v are two differentiable functions of x, then integral uv dx equal to u into first integral v dx minus integral next u minus integral du by dx into integral v dx into dx. This is the integration by part form, okay. In order to choose first function, we take the letter which comes first in the word late. I means inverse trigonometric function, L means logarithmic function, okay. A means algebraic function, T means trigonometric function, E means exponential function, okay. So, this I late means inverse trigonometric function, L means logarithmic function, A is algebraic function, T is trigonometric function, E is exponential function. So, this is the general topic is the integration by parts. Integral of the type. Integral of the type. Let's see what is the integral of the type. Integral e power x into f of x plus f dash of x into dx equal to e power x into this value is f of x plus c. Okay. Next, integrals of some more types. Let's see some more types of integrals. Integral square root a square minus x square dx value is x by 2 into square root a square minus x square plus a square by 2 sine inverse of x by a plus c. And second one is integral square root x square minus a square into dx equal to x by 2 into square root x square minus a square by 2 into log mod x plus square root x square minus a square plus c. And third one is integral square root x square plus a square dx equal to x by 2 into square root x square plus a square by 2 into log mod x plus square root x square plus a square plus c. Next topic is definite integral. Let f of x be an integral of f of x, then for any two values of the independent variable small x, say a and b, the difference f of b minus f of a is called the definite integral of f of x from a to b, and it is denoted by integral a to b f of x into dx. Here x equal to a is the lower limit and x equal to b is the upper limit of the integral. This is the definite integral. So, what is the definition of integral means? This is, here x equal to a is the lower limit and x equal to b is the upper limit of the integral. Okay. Next topic is fundamental theorem of calculus. Fundamental theorem of calculus. First fundamental theorem statement. Let's see what is the statement. You don't need proof. And next second fundamental theorem statement also just see. And remember what is the first fundamental theorem. Let f of x be a continuous function in the closed interval closed AB, and let capital A of x be a area function. Then a dash of x equal to f of x for all x belongs to closed interval a comma b. So, this is the first fundamental theorem statement. Next, second fundamental theorem statement. Let f of x be a continuous function in the closed interval ab, and f of x be an integral of f of small f of x, then this value equal to the f of b minus f of a. This is the second fundamental theorem statement. Next one is evaluation of definite integral by substitution topic. When definite integral is to be found by substitution, change the lower upper limits of integration. If substitution is t small t equal to f of x and the lower limit of integration is small a and upper limit is small b, then new lower and upper limits will be f of a and small f of b respectively. So, this is the evaluation of definite integral by substitution topic. Some properties of definite integrals. Let us see some topics of definite integrals. First property, integral a to b f of x dx equal to integral a to b f of t dt. Both are same integrals. Second one, integral a to b f of x dx equal to minus integral a to b to a f of x dx. Just interchange the limits, lower limits and upper limits. In particular, integral a to b f of x dx value is 0. That means here not b, a, integral a to a f of x dx value is 0. Third property is integral a to b f of x dx equal to integral a to c f of x dx plus integral c to b f of x dx, where a is less than c less than b. And integral a to b f of x dx value is here last fourth property, integral a to b f of a plus b minus x into dx. These are the properties of definite integrals. Next, fifth one is integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. Next one is integral minus a to a f of x dx equal to, here if f of minus x equal to minus f of x value is 0 in this case. If f of minus x equal to f of x, we will get the 2 into integral 0 to a f of x into dx. Next one is integral 0 to 2a f of x into dx value is integral 0 to a f of x dx plus integral again a to 0 f of 2a minus x into dx. Next, integral 0 to a f of x dx equal to, you can written as 2 into integral 0 to a f of x dx if in this case, and in this case this value is 0. Okay, thank you. This important note is finished in this chapter.